Hello and welcome to this video where we're going to learn how to use trig. And the learning target for this video is using trig to find side lengths and angles of triangles. Now, quick sort of disclaimer, this works only when you have a right triangle. Now, again, later there's some fancier trig stuff you can do for non-right triangles, but the stuff I'm going to go over in this video is all about right triangle trigonometry. Okay, so now we got to keep in mind what we learned earlier, which is that sine is the opposite over hypotenuse, cosine is the adjacent over hypotenuse, and tangent is your opposite over adjacent. Now that comes in that's a very important detail to keep in mind and remember. And so here's what a problem might look like. Let's say we have a triangle, looks like this. It is a right triangle, and we're told that this is let's see which one. We're going to do this. This is 35 degrees. This is 8, and we want to figure out what that side length is. All right. Now, step 1 is to take a look at what it is we have. And what I'm seeing here is we have this angle, and I have the adjacent side, and I have the hypotenuse. So adjacent side and hypotenuse makes me think I want to use cosine. And so here's how I set it up. Cosine, now instead of using a variable, cosine is a ratio from a certain perspective, and it's the ratio from this perspective, and that perspective happens to be 35 degrees. So cosine of 35 is equal to x over 8. And now what I have here is, this is going to become a number, and you'll see I have a calculator over here because you're going to need it. And what I do is I just go to my functions, I find cosine, I put in 35, and now I have a number for that. And if I take a look at the algebra that's going to be needed to solve for x, I'm going to have to multiply both sides by 8. And so once I figure out what this is, make sure you close those parentheses, times both sides by 8, and there we go. X roughly has to equal 6.55. And that's how we use trig to solve some right triangles. Now, let's do some different examples, and let's try to kind of mix it up with everything else that we can do here. All right, so let me go back to my ink. Let's go with black. Now this time, let's say I have this triangle right here. This is 25 degrees. I'm going to put my 8 down here. And I want to find both sides. All right? So now for this one, what I can do is take a look at what I have. If I want to find x, so we'll go finding x. I have an angle, and it looks like I have the opposite side, and I have an adjacent side. So using those two things, opposite and adjacent, means I'm going to need tangent. So I will go tangent of that angle, which is 25 degrees, has to equal x over 8. And we're going to do the same thing. Multiply both sides by 8. Go to my calculator. Tangent of, oops, not 8. Tangent of, parentheses, 25 times that by 8. And here, x roughly has to equal 3.73. Now, going to the next one, y, looks like I have, so if I look at y, I have the hypotenuse and I have the adjacent. So I'm going to go back to cosine. So cosine of 25 degrees has to equal, in this case, same thing, x over 8 times both sides by 8 times both sides by 8. So 8 cosine of 25. X has to equal, let's see, our hypotenuse has to equal, uh-oh, that doesn't make sense. What's going on here? Opposite. Oops. Oh, no. All right. I see the mistake I made. All right, good thing I did that so we can all learn from this, right? All right. Slow it down. So, cosine of 25 is going to equal 8 over my hypotenuse. I don't know what my hypotenuse is, so I have to figure that out. Now, in order to do this, I'm going to have to do some fancier math. I'm going to multiply both sides by my hypotenuse. All right, so that way I cancel out here, and I have my hypotenuse times cosine of 25. Now, the great thing with this is that we just saw that all these cosine, tangent, if I put in sine, these things are just numbers. So I can now divide both sides by cosine of 25, divided by cosine of 25. So my hypotenuse is going to equal 8, whoops, I already have 8, divided by cosine of 25, and that means it is roughly 8.83. And so there I have my missing side length. Now this is just using the trig functions to find missing side lengths. We could use them also to find angles. So let's clean this up and let's talk about how we do that. So we'll get rid of all that stuff. Now in order to do this, we need to introduce some different trig functions. And you can see them right here beneath my sine, cosine, and tangent. I want sine inverse, cosine inverse, and tangent inverse. Now what those things do is they undo my sine, my cosine, and my tangent depending which one I have. So let's look at a new problem. And let's say, go back to black. I have a right triangle that looks like this. I have a base of 7 and a height of 4. And I want to find out what x and y are. Now, finding x, finding y. Now if I look at x and I look at what I have the opposite and I have the adjacent. Opposite and adjacent, that's leaning me towards tangent. And so what I want to do is I want to set it up. Tangent of x is going to equal 4 over 7. Now the thing is, I'm trying to figure out what x is. And right now I'm taking the tangent of it. And in order to get rid of the tangent, I need to take the tan inverse of the tangent of x. All right, and what ends up happening is that cancels it out. Now, you just usually write it down. You don't have to put it into a calculator. But then on this side, I'm going to write tan inverse of 4 over 7. And then that's what I'm going to use to determine what I have going on or for what my angle is. So if I go, let's see here, tan inverse, back to the main, 4 divided by 7, that means that x roughly equals 29.74 degrees. And so that's how I use trig to find a missing angle. All right, and if I want to, I could do the exact same thing for finding y. So again, I have the opposite and the adjacent. So I'm still going to have to use tangent. So tangent of y is going to equal 4 over 7. And then, oh no, sorry, it's not 4 over 7. It's going to be 7 over 4. Pay attention. 7 over 4. Very good. I want to apply the tan inverse of both sides. So I'll do the tan inverse of that and then the tan inverse of that. So y is going to equal the tan inverse of 7 over 4. And taking a look at it, it should be about 60 degrees, give or take, because this 30 plus that 90 and then whatever y is better add up to 180. And so I plug it in. Functions, tan inverse, go to the main, 7 divided by 4. And there we go. Y is roughly equal to 60.26 degrees. And there we've found some missing parts of right triangles by using tangent. Now, the examples, I didn't use any sine, but it would work out the same thing. In order to use sine, I would need something like this. I have my right angle, and let's say I have 4, and I need to figure out what my hypotenuse is, and then I knew what this was, so let's just kind of throw a number on it. Let's say 33 degrees. There, I have opposite and I have hypotenuse, so I could use sine. Likewise, if I had, let's say 4 and 5, and I wanted to figure out what the angle was, I have opposite, I have hypotenuse, so I would go sine inverse of 4 over 5, and that's how I'd find that missing angle. But it really hinges on still understanding what those ratios are, and then being able to plug those numbers into our calculator. So, good luck with your homework or practice, and let me know if you have any questions.